Today's lesson is about proportions and similarities. As a reminder, a proportion is simply an equation that states that two ratios are equal. So for example, 244 divided by 100 is a ratio. 336 divided by 150 is also a ratio. And when we set them equal, we have created a proportion. When solving problems involving proportions, we often use cross products. Cross products are the product of the numerator of one ratio times the denominator of the other ratio. So the two cross products for this example would be 244 times 150 and 100 times 336. The property known as the equality of cross products, and it says that for any numbers a and b and any non-zero numbers b and d, a divided by b is equal to c divided by d if and only if a times d equals b times c. It's very important, of course, that b and d be non-zero numbers because, as I'm sure you know, we can never divide by the number 0. So a problem involving a proportions example would be one such as 3x minus 1 divided by 4 is equal to 7/8. In order to solve this problem for x, I would set up the cross products as 3x minus 1 times 8 is equal to 4 times 7. I would simplify to get 24x minus 8 is equal to 28. I would, of course, add 8 to both sides and get 24x is equal to 36. In order to solve for x, I would simply divide both sides by 24, and I would get x is equal to 3/2. That's just a quick reminder on how proportions are used. The way we most often use them in geometry is to solve problems involving similar polygons. Similar polygons are two polygons that are similar if and only if their corresponding angles are congruent and the measure of their corresponding sides are proportional. So we're dealing with two different concepts here. We have angles that are congruent and sides that are proportional. In this particular example, I have two similar polygons, polygon ABCD and polygon EFGH. As you can see by the markings, A corresponds to E. These are congruent angles. Angle B and F are congruent. Angle C and angle G are congruent, as are angles D and angle H. Since the angles are all congruent, in order to conclude that these polygons are indeed similar, I have to prove that the sides are proportional. And I could set this up by saying that side AB is proportional to side EF. This would have to be equal to the same ratio as saying side BC divided by side FG would also equal CD divided by GH, and the last two sides as well, DA divided by HE. If it's true that all of these pairs of sides are proportional, then indeed my polygons are similar. So let's test it out. 5 divided by 10 is indeed equal to 6 divided by 12, which equals 8 divided by 16, which is equal to 10 divided by 20. When simplified, all of these fractions come out to be 1/2. So we would say that these two polygons are similar and they have a scale factor of 1/2. Scale factor is simply the ratio of lengths of corresponding sides of similar polygons. In this particular example, I have two polygons, the first being RSTUV and polygon ABCDE. As you can see from the angle markings, angles A and R are congruent, B and S are congruent, C and T are congruent, D and U are congruent, and E and V are congruent. In this particular case, I happen to know that side BC is 4 units, DC is 5 units, and AE is 3 units. I also know that RV is X units, ST is 18 units, and UT is Y plus 2 units. If I wanted to find the scale factor of the polygons, I will use the two sides that I know, which are BC and ST, and I would set up a proportion such that I have side ST to BC, which is 18 to 4, or 9 to 2 when simplified. I can use this proportion in order to find out what X is, because I know that ST to BC must be equal to RV to AE. This means that 18 is to 4 as X is to 3. So I get 18/4 equals X over 3. I cross multiply in order to solve, and I get 18 times 3 equals 4 times X. That tells me that I have 54 equal to 4X. I would of course divide both sides by 4, and I would find that X is equal to 13.5. So now I know what X is, 13.5. In order to solve for Y, I can use the same ratio I used the first time, 18 to 4, or I could plug in now the 13.5 to 3. I'm going to use the first pair just so I don't have to deal with decimals when multiplying. In setting this up, I'm going to say that ST is to BC as UT is to DC. Okay, let me slide that a little bit. So what I'm going to find then is that, again, I have 18 to 4 is now going to be equal to Y plus 2 to 5. I will then do my cross multiplying and get 18 times 5 equal to 4 times Y plus 2. This gives me 90 equal to 4Y plus 8. Of course, I would subtract 8 from both sides. And I will get 82 is equal to 4Y. Divide by 4 and find out that Y is equal to 20.5. In order to find the scale factor, keep in mind that I did that in the very beginning. That was my 18 to 4, or 9 to 2. I then used this scale factor in order to find out the lengths of unknown sides.
Oops!